quickly. In this video, we're going to go over the constant velocity lab. In particular, this is pertaining to questions C and D, the graphical analysis. So in AP Physics, we do a lot of graphical analysis, and this is just your beginning steps. So let's just do a quick recap. So for the lab, what you did is you had a car, and that car moved across the floor, and for every some amount of time, you took the time interval T1, T2, T3, T4, T5, T6, right? So on and so on and so on. And then at each one of those, you would get x of 0, x1, x2, x3, x4, x5, x6. And so when you did this, what you ended up with is a chart, and this is a position versus time chart. Now it's going to be more detail oriented. Make sure that you always have your units and your variables. My units will always be in parentheses, and next to it will always be my variables. And hopefully you got enough data points. So let's say at time 0 you were at position 0, and then we got at 1 second, 2, 2 seconds, 4, 3 seconds, 6, and 4, 2, 4, 6, and then 8. Okay, and so let's say that is your data table. Now I just use whole numbers. You might have decimal places, but that is a-okay. So what you want to do next is you want to plot a position versus time graph to determine exactly how fast your car was moving. Now, to be specific, for a position versus time graph, what you were trying to find is the velocity of your cart, right? So that was the whole purpose of the lab. So we're going to get into this a lot more later, but the general cheat code for what is on my x-axis and what is on my y-axis, okay? So for this class, I need you to basically just forget about the whole idea of the independent variable and the dependent variable, right? So I know that you were taught that the x-axis had the independent variable and the y-axis had the dependent variable, but for this class, get rid of that idea. So the way to figure out what is on the x-axis and what is on the y-axis is by using a physics formula, okay? And so this is why the table in variable form is so useful, along with the actual thing that you are solving for. So what you have to ask yourself is, what is the formula for velocity? And if you've been keeping up with your notes, then you know that velocity will be the change in position over the change in time. So the skill that I want you to use for this class from here on out is the idea of what the graph can tell us in terms of graphical analysis. So I guess a clarified way of putting this is, if you have a fraction, okay, so for a fraction, what you are looking at is essentially the slope, okay? So here, this is the change in the y-axis. I'm just going to call it the rise. And down here, this is going to be the change in the x-axis, and I'm just going to call that my run. So in math class, you would have learned this as delta y over delta y over delta x. Now, it's important to know that this delta x here, okay, is not change in position, but the change in the x-axis, okay? And much like here, this delta y is not the change in the y position, but just the change in the y-axis. So if I take a look at this formula and I see that my formula is delta x over delta t, that means my position is in the y-axis and my time is in the x-axis. So I'm going to go ahead, I'm going to redraw this. So that means position is in the y-axis, meters, and time is in the x-axis, because this is my rise, and here, this is my run. Now, this applies if your formula has this very clear-cut division in it, okay? Now, the other important thing is, what does the rise over run represent? And I have the answer, and the answer is down here. The rise over your run, aka your slope, which is your fraction, okay, in this formula, that slope is your velocity. So if I were to plot these data points, right, I'm just going to roughly do it. We would have 0, 0, and then we would have 1, 2. So I'm going to put that in parentheses, and then we would have 2, 4 right there, and then you will get the trend. So I would just plot out the points normally, okay? And then here's the important thing, okay? You have to use a straight edge for AP Physics, okay? So with your straight edge, you want to create a line of best fit, okay? So line of best fit means that you're just following the general trend. You're going to try to hit as many points as possible, but make sure it's actually following the line. And I'm going to try to create a straight line here. Boom. All right. So I would be dinged because I'm not actually using a straight edge, but I'm on my tablet. So make sure you use a straight edge, because if you do not use a straight edge, the AP grader has all of the justification in the world to say, it looks sloppy, 0 out of 1. And that's an easy 1 point that you could get, right? And so if I were to find the slope of this line, okay, here's the other important thing, and this is something I want you to practice. It is important that you cannot use actual data points. So I'm going to actually write that down. So if you're taking notes, you should have this down. Okay, to find slope, you cannot use data points from the table or the lab. Okay, so for a FRQ, right, the official FRQs for the data tables, they'll give you data points, and you cannot use those data points to find the slope. And so what you have to do instead is on your graph, okay, you need to find points on the line. So I'm going to find, so this will be point 1, and right there, this will be point 2. So notice that those 2 red circles that I just circled are not actually data points. Now here's an important thing, right? I'm showing you the very exact thing that you should be doing. You should be circling the data points that you are going to be using, call it P1, P2, or like the coordinates, right? And then you have to say like that's a indicator that you are using those data points and not the data points. They're very harsh on that. You cannot get the point for finding the slope if you find the slope using their data points. Okay, they cannot be data points. So I'm going to say it like this: circle 2 points on the line that you'll use to find the slope. Okay. All right. Now, this is, of course, finding the slope manually. Later in the year, I'll show you how you can do this through Desmos, because you are going to have full access to Desmos. But for now, let's do this manually. All right. And then you're going to show the math to find the slope. And in this case, my slope would be, I don't know, it's going to be, what did I say? It's going to be 2 over 1. So my delta x would be 2, and my delta t will be 1, so it'll be 2 over 1, right? So I'm going to write it out like this. Now, notice what I'm doing right here is I'm showing the grader, hey, I know that my slope is equal to 2 over 1, or 2, and I know that my slope is equal to velocity, right? You're showing them exactly what you're doing. You want to be as clear-cut as possible. You want to leave 0 stones unturned. So make sure on this intro lab, you do the same thing, all right? Show the 2 data points that you use to find the slope. Make sure you show your math. I know I didn't, but make sure you do to find the velocity. Just another quick tip. When you are finding the 2 data points, when you're using your graph paper, I suggest that on the graph paper, you look for the data points that go through the crosshairs, okay? So that you're not like, oh, this is like 0.1 or 0.2 or 0.15 or 0.16, right? So you don't have to go through those hurdles. Circle the data points that actually go through the crosshairs. Or excuse me, circle the points that go through crosshairs, not data points. Okay, and that should be enough information for you to figure out exactly how fast your constant velocity car was going. See you next time. Bye-bye.